Good evening. I'm Danilo. I work in Jan's team. I cover a few countries across Europe, Middle East, and Africa. And today I would like to introduce you to the new Amazon AI services, the one that we announced in re:Invent. Since we saw a few slides with Jan, the idea tonight is to just do live demos and see how they work. And so this is the only slide that I'm presenting tonight. If you need to reach to me, that's my Twitter handle. It's also my GitHub account. It's also my email at amazon.com. So Amazon AI. Amazon AI is the new way of sharing what we built inside Amazon. We have thousands of engineers working on machine learning and deep learning technologies and share this technology that we build inside for any developers to use without having the requirement of understanding how machine learning or deep learning works. And in this Amazon AI initiative, the first three services that we launched are, as we saw, Amazon Lex. The idea is to build, to take the engine that we use to build Amazon Alexa, to build conversational interfaces, and to open this not only to voice, but also to text, so you can easily build chat and chatbots. The second one is Amazon Recognition, to recognize details and faces in pictures. And Amazon Polly to provide a lifelike experience in speech, in text-to-speech. So let's start with Amazon Polly. It's the easiest one to introduce. So this is a very simple API. I'm showing the console, but you will probably use the console only for testing. You give it text or SSML, that is a markup language to express a more complex speech syntax. And we support quite a few languages, more than 24 languages. So there is a few flavors of English, French, Italian, that's important for me, and so on. And for every language, we have multiple voices, male, female, sometimes children. And you can use this as an API in your application, so you can do web notification, you can use it in games, you can use it even in embedded environments, so you can have maybe a specific IoT device that can notify you with voice of something that is happening. So let's test just this basic voice. So now this is the default one. Let's see the difference, and you can judge. So just to check that the network is working, because I refresh the page, I see, no, it's working. Is the audio on? It's on, yeah. So let's double check that it didn't change the sound connection. So it's on the headphones.
Hi, my name is Joanna. I will read any text you type here.
OK, let's move to British English. And let's take Brian.
Hi, my name is Brian. I will read any text you type here.
So the idea here is really to provide a smart experience. And as Ian already pointed out, we expect the text to find the right pronunciation for different words. So for example, I have this very basic sentence here. And as you can see, the word live and live is pronounced differently depending on where it's placed in the sentence.
I live in New York City. This presentation broadcasts live from New York City.
So live and live are pronounced differently. And as we said, we can use markup languages to have more control on what we say. So for example, my family name usually is not easy to pronounce. So now I have this piece of code that says,
the spelling of my last name is Poccia.
That's perfect for me. It's solving a lot of issues. So this is, of course, working for standard words. If you have specific product names or a specific jargon that you want to cover, you can add custom pronunciation. You can create a lexicon that you can connect to your voice so that you can really tailor the specific product names that you use or specific jargon that are outside what we cover. So this is Amazon Polly. It's really a very simple API. You give text or SSML, and you get the voice back as an MP3 or in PCM format. The second one is recognition. So recognition, let's reload the standard page. Recognition can do basically three things. The first one is to look for details inside a picture. So this is a sample picture, and we list you all the details as labels. And for each label, we'll give you an accuracy factor from 0 to 100%. And you can filter the features that you get. For example, the default is to get only everything that is 50% or higher in accuracy, but you can change this to get maybe higher accuracy or lower accuracy because you want to have more details. You can also give, in the API, a maximum number of features, so you can say, give me only the top 3, without looking at the accuracy level that I get. And this is a really nice interface for developers because you can also see the payload of the HTTP request that we produce and also the response back that you get. So you see there's a JSON payload with all those labels with the confidence score. And this is the first one. So for example, I can upload maybe a couple of pictures. So this is a picture that I took in Japan. There was this ancient temple where animals are so friendly you can approach them, and this is the result. So I'm not sure if it's a deer or an elk, but I think we are on the same page, me and the service. Then there is maybe this one is just to show a low quality picture. So sometimes when you take a picture, especially with a smartphone, you don't get high quality details. So this is from the AWS Summit in Barcelona. We did some nice music afterwards, and the lights were very dark. So this is what my smartphone got out, but still we recognize this is people, person, human, a guitar, a guitarist, a musical instrument, so the picture is recognized. So you don't need high-level, high-quality pictures. It works also in not so good condition. Another feature is facial analysis, so it will detect faces in a picture, and it gives you some feature of the face, so it can tell you if the probability of the sex, in this case, it appears to be a female, some emotions, so it's smiling, it's happy, maybe it's sad, and some additional information like is wearing eyeglasses, is wearing sunglasses. We can detect up to 15 faces in a single picture. So for example, here you can see if I move on here, you can see that he has a mustache, he has a bird, and so on. So this is the kind of information we can extract from every single face that we detect. The third one is face comparison. And face comparison can work in two ways. One is to give just two faces and compare them, and we give a similarity score. So as you can see here, starting from the picture on your left, we are understanding that the person is the second one in the second picture, and you can see that the position of the face, the lighting is different. We also have seen some examples where actually I didn't recognize that it was the same person, but the machine learning algorithm was. And in this way, you can look for a single picture in a single face in another picture. The other thing that you can do is to create a collection of faces, and then you can search in a picture if there are faces from this collection. And this is a more advanced use case for face comparison. There was a demo that our colleague Tara did, where basically they were taking a snapshot every few seconds where people was passing by, and they were extracting the mood of the people, so recognizing the face, seeing if they were happy or sad, and extracting the mood, the average mood of the people passing by in a corridor. So it opens a lot of interesting use cases. The SDK is very easy to use. You have detect faces, detect details, and the comparison tool for faces, where you can create a collection or just compare a face in another picture. The third one is the more advanced services, in my perspective, because it opens a new way of building applications, and it requires to understand how the flow works. So this is Amazon Lex. The other two services are in general availability, so you can go test and play with them. There are free tiers, so that you can start for the first year and playing with the services without any cost. Amazon Lex is a tool, so it's the engine at the center of Amazon Alexa. And the idea is to create a bot that can answer to voice or text, so you can use the same configuration, the same bot with a voice-enabled application or with a text chat. And the first element that you can create is the bot. So let's use a very basic bot here. This is the order flowers bot, so a very basic bot to order some flowers. And when you create a bot, you can create one or more intent. The terminology is similar to the terminology that we have in Amazon Alexa, but it's not one-to-one, so it requires some attention. So the intent are basically the actions or the functions that you want to build into your bot. In this case, it's a very simple bot, so you have a single action, just the possibility to order flowers. We will see another example with 2 intents. Then when an intent is created, you can give sample utterances. You see now everything is blacked out because Amazon Lex supports versioning. So now I'm in a specific version, and versions are not editable, but you can always go to the last version, and then on the latest version, you can edit and create a new version. So you can link sample utterances to an intent, and this is what we use to map the voice or the text of the chat to this intent. And we do the voice recognition, but on top of that, we also do some natural language processing. So you have to give a few examples, but we will add some magic on top of that. So for example, if I change a little bit the sentence, they will be automatically mapped without requirements. So I would like to pick up flowers. I would like to order some flowers. And if we go into this intent, then you can declare the slots. The slots are the variable that are required to fulfill this intent. So to order flowers, I need to know the flower type, the pickup date, and the pickup time to get these flowers. So pickup date and pickup time are standard slot types that we support, are a Amazon date and an Amazon time. And then I can give an idea of the question that must be asked to get this information. So for a pickup date, what day do you want the flower type to be delivered, and at what time do you want the flower type to be delivered? You see, I'm specifying the flower type here because there's a priority in the slots. So I always know that the slot 1, the flower type, is the first one to be fulfilled, and then I move on the other ones. So I can assume that I already know the flower type in the second slot, and so on. If you click here, you also have more information, so you can create multiple utterances. So those are the answer to the question to fulfill the slot. So if you want to specify a flower type, you can say, I like roses, or you can just say roses, or I would like to order roses. So all these utterances can be also configured for every single slot. And you can also create a response card, because this can be run via voice, via chat, but most of the chat engine, such as Facebook Messenger, they support cards. So for example, you can create a card here and say, for example, that I want to give this as this is the flower type, so flower type. And then here I can give some standard value like tulips, lilies, and roses. And this is creating a card that you can see here, that will be shown to the user, so that if the user doesn't want to write or answer via voice, he can just click on the card. And all the chat engines, they have their own markup languages to describe these cards. We do automatically the translation to the one that we support. At the beginning, we will support Facebook Messenger, and then we will add support for Slack, and also an integration with Twilio, and then we will listen to your feedback to understand which platforms to support on top of those. So here I created the utterances, the slots, and then you have the confirmation prompt. The final one is the way to say, OK, this is usually important for an intent to say, OK, you want to order this kind of flower on this date and this time, and then you can answer yes or no, and then you can either place or cancel the order. When I have all the information for an intent, I can call a Lambda function that I can put here, and then I can have a goodbye message if this intent ends the chat, or I can have a follow-up message saying, OK, what can I do again for you? So for all these chats, when you build the engine, you can test the bot live here. So for example, let's go here and I say, I'd like, let me zoom a little bit, like to order flowers. And you see it's not exactly the same of what it's in the sample utterances. I changed a little bit the wording, but it was recognized by the engine. So this is the natural language processing part. So let's say that I want roses. And here it's where the utterances of the slot is used. What day do you want the roses to be picked up? This is interesting. So for example, for the dates, you can really use something that is a conversation here, like maybe I can say tomorrow. And it will say on what time on the 8th of December, so it's automatically translating tomorrow into the actual date, and I can say at noon. So, okay, you want to pick up your roses at 1200 of December the 8th? Yes, I can confirm. So now the bot was in a simple configuration that is just to return the parameters to the client, so I get the final parameters that would be passed as part of the event to the Lambda function that can fulfill the intent. A more advanced example is the book trip. So the book trip example is an example where I have a book car and a book hotel intent. So I can either book a car or an hotel. And for each one, I have, of course, different parameters. So to book an hotel, I need to know the city, the date, the number of nights I want to stay. Let's put it into latest days. And you can choose the room type. So for custom slots, like the room type or the flowers type, you can create your own slot type. So if I click here, I can go on room type values. And for example, in this case, I have king, queen of deluxe. And again, we are not restricting values to this one. So we will try to use this to understand which room size is given by the user. But if the user says something completely different, we can pass that to the Lambda function. And so you need to double check the values that you receive. We will use this more of an indication of what the customer can say, not what is not restricting the values of the parameters. So now here I have another bot, and I can test it again. So let's clear. So let's go here in the book car, for example. And just to give you an idea, maybe without entering into all the examples, this is an example of utterances for the book hotel, where I have an utterances that is just, I want to book an hotel, I want to make a hotel reservation, and then you start fulfilling all the slots. But you can also have a starting utterances for the intent that already pass some information. So I can say book a 4-night stay in London, and this will automatically prepopulate these 2 slots, and then only the slots that are still empty will be asked by the chatbot engine. Okay, so with this, I think I've given you an idea of the 3 services that we launched. Let's just do a very, very quick recap. So we have recognition to understand the details, the labels that are in a picture, and also to do face detection and face comparison. Amazon Polly to do a quite interesting text-to-speech. We saw how different words. Another example that you can maybe play on the console is, in English, is ST, that can be either a street or a saint. So depending on the context, we understand which one to use. And then Amazon Lex. I just show actually the example here, but here in the channels, we already have the integration with Facebook Messenger. So in the channel, you can publish a chatbot, and this will automatically prepare for you the webhook that is required on Facebook to configure the messenger. And we are planning to do the same for other platforms such as Slack, and also Twilio for an enabled application. There is a nice example that was published on the Elastic GitHub account that you can play with. It's actually Polly with Twilio. So you can just, you have a command line interface where you can write a sentence and then give a phone number, and it will use the Twilio API to call that number and speech the sentence that you wrote there. So maybe if you have a script, like a DevOps script, and you want to receive a phone call with some descriptive message, you can just grab that and put it into your account. You will probably be in the free tier unless you have a lot of notifications and play with the technology in the free tier. So with this, it's all. Thank you, and let's go on the next presentation.
Wow, I don't know about you, but I absolutely love that. One question, or half. Anybody? No? Okay, okay. There you go.
When do we get dynamic slots?
Dynamic slots?
Yeah, so we can have just any value in a slot.
What kind of
the values are pre-selected, so you put
No,
like-
but they are actually not binding. So the values are used by the text-to-speech natural language processing to understand the closest value depending on the person that is speaking. But especially if you interact via text, if you write a completely different value, we will pass that value. So if you write, for example, in the case of room type, you remember there was deluxe. If I write deluxe and I misspell one character, we will correct it to deluxe. If you write something completely different, we will pass that value already. It's just an indication. So our recommendation is the lambda function must always double check the values because they are not restricted. It's just a hint for the voice recognition engine to understand what to pass. Did I answer your question?
Thank you so much. A round
Thank
of
you.
applause for Danilo.